Welcome to template metaprogramming in C++. We will have a look at the techniques used in template metaprogramming, and we will have a look at an example how to implement isSame to check if two types are the same or different. Let's start with the techniques we use in template metaprogramming. Any program we write in any programming language, we use one of these three tasks. We initialize variables or objects, we select branches, and we do loops. In normal programs, we achieve these tasks by these techniques. Initialization, we achieve it by means of constructors. Selection, we achieve it by means of if-else statements. Loops, by means of for or while. In template metaprogramming, on the other hand, we use different techniques. Our template metaprograms have to run during compilation and finish running when the compiler finishes compilation. And for that, we use techniques used by the compiler as it compiles our code. So initialization, to achieve initialization during compilation, we need to use the modifier constExpr. This will make sure that our variables are initialized during compilation. On the other hand, we use static modifier to make sure that we can access members of structs without the need to create objects of that struct. Selection, we use template specialization. Because compiler, when it looks for definition for our structs, it will check the specialization first. If it doesn't meet the requirements, then it will check the general template. And finally, loops in template metaprogramming are achieved by means of recursion. And really, this is all what we need about template metaprogramming. For our example, isSame, to check if two types are the same, we just need the first two tasks, initialization and selection. Let's see how we can use these two techniques. Here is the general template, isSame. It takes two parameters, two types, tu, and it will check if these two types are equal or not. Inside the struct, we have value member. As we can see, we initialize it to false, and we use static constExpr. As we have seen here, initialization, static constExpr. By default, it will be false. And then we need to check if the two types are equal, we want to set this value to true. If equals, so we need to implement if statement. So for that, we need template specialization. So we need to specialize this template, and here is our specialization. So when compiler sees isSame, it will first check this specialized version. If it sees that this version satisfies the requirement, meaning if we have really the same type here, then value will be assigned true, and this struct will be the one which is called. On the other hand, if we have different types here, compiler will fail to use this isSame because it will not be able to substitute different types here. And as a result, this definition will be ignored, this specialized version will be ignored for different types, and compiler will check the general struct and see if this meets the requirements. And if they are different, for sure, this is the one which will be called and value will be assigned false. And that's all. This is our isSame template. We can use it to check if two types are equal or not. And let's see an example. Here is isSame. We have two integers and we access the value without the need to create an object of isSame. We store it in a variable, and we do the same for integer and string, different types. We access the value, store it in a variable, and we print the values, and we get this result. Everything happens during compile time. And that's it. I hope you enjoyed the video. Thanks for watching, and see you next time.